Assalamualaikum and selamat sejahtera. Today, our group will present our NDT assessment for an aluminium component by using ultrasonic testing. This project was carried out to identify possible defect, evaluate their severity, and propose suitable corrective action. For this assessment, we be selected an aluminium plate that may be used for machine guard or structural component. The ultrasonic velocity for aluminium is 6,320 meters per second. Before we conduct the inspection, we predicted several possible defects. These include generalized corrosion and erosion on the front and back surfaces, pitting corrosion at localized area, and uniform wall thinning caused by chemical and mechanical wear. And we also predicted that the defect would mainly occur on the front and back surfaces, while the left and right side would remain close to their original thickness. So, as you can see, this is our sample that we measured for the right side and the left side. And also we also measured the thickness, front side and also the back side. The NDT method chosen for this inspection is ultrasonic testing using the pulse echo technique. This method is suitable because aluminium is a homogeneous material with a known ultrasonic velocity. Ultrasonic testing is highly effective for detecting thickness loss and measuring remaining wall thickness accurately. Additionally, it only requires one site access. Is safe because it does not use radiation and the equipment is portable and easy to operate. Therefore, ultrasonic testing is the most appropriate method for this assessment.
Next is our key factors in NDT planning. Our first consideration is the velocity set to 6,320 ms. Second, gradual thickness loss is 5 mHz probe. And next, surface was clean and smooth coolant was applied. And straight beam probe. Low cost, only coolant gel and basic UT gauge and V1 calibration block. No special precautions required. A grid measurement approach was used. Next, our procedure. The equipment that we use is first, ultrasonic thickness gauge, 5 mHz twin crystal straight beam probe, V1 standard calibration block, clean cloth, aluminum test specimen, and coolant gel, which is water-based. First, we need to clean all the specimen surface with cloth. Next, we apply the coolant gel to the V1 block and calibrate the velocity to 6,320 ms at 25 mm test range. Next, we adjust the gain. So, first, back well echo, which is 80% full screen height. Next, apply the coolant to aluminum specimen and place the probe perpendicularly to right side. After that, record 3 thickness reading and repeat for the left side, front side, and back side. Lastly, calculate the average thickness per location. First, coolant was applied onto the surface of the workpiece. Next, we use the probe and put it on the surface of the workpiece where we want to inspect. And then, the graph show the data that we want to analyze. Then we collect the data and we analyze all the data we needed.
After recording our data, we observe a clear discrepancy, while the left and right sides maintain an average thickness of approximately 102.3 mm. The front and back sides show significant thinning, with an average of approximately 88 mm. From the observation data, we detect the defect. It has 14% thickness reduction, which is uniform wall thickness reduction. We analyze the root causes, identifying potential factors such as galvanic or chemical corrosion, mechanical abrasion or erosion from high velocity particles. From a risk perspective, this 14% reduction is critical. We categorize the risk level as high, as unaddressed defects could lead to plastic bending deformation, through wall leakage, or even stress corrosion cracking.
Okay, for improvement recommendation, first is material change. Switch to a stronger coated aluminum that resists chemical damage. And then alternative material. Use the use a different stainless steel that handle corrosion much better. And for process improvement, which is add a small zinc part that corrode instead of the main part. And then process improvement. Clean the liquid or change how to flows the particle don't eat away the surface. Design change. Make the part thicker to begin with begin with. So even after 14% wear, it's still safe. And the last one is inspection schedule. Check the thickness every year at 10 fixed spot 10, 10 fixed spot to catch problem early. Okay, for conclusion and YouTube link. Conclusion is uh, ultrasonic testing successfully detected a 14% wall thickness reduction on the front and back face of the aluminum plate from 102 mm to 88 mm. The most likely root cause of is corrosion and or erosion from the service environment, with the left and right edge remaining the original thickness. The defect severity the defect severity represent a high risk of bending deformation, leakage, or stress corrosion cracking. Immediate replacement is recommended along with material or coating improvement and an annual UT inspection. Okay, that's all from our group and thank you.